Today we're going to talk about graphing equations in standard form. So standard form is this form ax squared plus bx plus c. And you might remember that from when we were using the quadratic formula. So standard form has a couple of similarities to our factored form. Our a value is pretty much the same. So if it's positive, it's going to open up. If it's negative, it's going to open down. The larger a is, the more narrow your parabola will be. The smaller a is, the wider it will be. Remember, this doesn't, when you talk about larger or smaller, it doesn't matter if a is negative or positive. It just matters how big the number, the absolute value of the number is. So for example, like a half, negative fourth, these are examples of something that's wider. 2, negative 3, 4, those are examples of something that would be narrower. What's new for standard form? So for standard form, in order to graph our parabola, remember we need our vertex, right? Our x, y for our vertex. So in order to find that, we're going to use this formula, negative b divided by 2 times a. Okay, so when we use that formula, that's going to give us our axis of symmetry, and it's going to give us the x value of our vertex. So if we sketch a parabola here and think about this, right, our axis of symmetry, it's that line that's cutting our parabola in half. So that would be, we could find that using our formula, negative b divided by 2 times a, and then that's going to be the x value of our vertex. And of course, once we have x, we can substitute that in to find y. We're also going to learn a trick for our y-intercept. When you're thinking about standard form, your c value is always your y-intercept. Let's practice. We want to graph y equals x squared minus 2x minus 3. All right, well, a is 1, b is negative 2, and c is negative 3. So since a is 1, I know this is going to open up since that's positive. Well, to find my axis of symmetry, I need to use that formula. X equals negative b divided by 2 times a. All right, so this becomes a negative 2, because my b value is negative 2, divided by 2 times my a value, which is 1. And now I simplify. So I'm going to simplify the numerator and then the denominator, and then I'm going to divide. So I know that a negative times a negative 2 is really a positive 2. In my denominator, I know that 2 times 1 is a positive 2. And I know that 2 divided by 2 is a positive 1. Hey, there's my axis of symmetry. And I'm actually going to graph that. Here is what an axis of symmetry of positive 1 would look like. That's the line where x is always equal to 1. Well, since we have our axis of symmetry, we have half our vertex. We just need to find the other half. And remember, anytime you have an x value, if you want to find y, we just substitute. So our equation was y equals x squared minus 2 times x minus 3. We're going to substitute that axis of symmetry in for x. So it becomes 1 squared minus 2 times 1 minus 3. Well, 1 squared is 1. Negative 2 times 1 is negative 2. Okay, we're just using our order of operations here. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So we have a vertex of 1, negative 4. And again, I'm going to put that, I'm going to use a different color. I'm going to put that on my graph. Here's 1, here's negative 4 on my axis of symmetry. Okay, so we have 1 point, but obviously we need a few more points to make our parabola here. So our y-intercept, that's pretty straightforward to find. So I know that my y-intercept is going to be negative 3 because my y-intercept is always our c value. But let's take a second and think about why that happens. So to be the y-intercept, we know that x has to be 0 because that's just what it means to be on your y-axis. So if we think about substituting 0 in to standard form, we get 0 squared minus 2 times 0 minus 3. Well, that's just 0 plus 0 minus 3. And it doesn't matter what your standard form equation is, the x squared and the bx term are always going to be 0, and all you're left with is that c value. So that's why instead of substituting 0 in, we can always just know that c is our y-intercept. Okay, well remember, our parabola is symmetric, so if I know that 0, negative 3 is a point, here's my 0, negative 3, I can mirror that over here, so it looks like 2, negative 3 is also a point. So we've got 3 points right now. Let's put them in our table. We have our vertex, 1, negative 4, and then from our y-intercept, we have the point -3, and then when we mirror that, we have the point 2, -3. Okay, but typically we want 5 points just to give us a good idea of how wide or how narrow this is going to be. So we are going to pick another x value. We can pick any x value we want. It does not matter, okay? But we want to try and keep it close to the x values we already have. We've already used 1, 0, and 2. So I'm going to pick something close. Like I could do -1, I could do 3, maybe 4. I'm not going to pick 10 or even 5. That's getting far away. The farther away I am from my axis of symmetry, the less likely my points are to fit on my graph. So again, it doesn't matter what x value we pick, but typically we try to pick something close to the x values we already have. So I'm going to pick 3 because, right, 2, 3, those are really close. And that just means we substitute again. Lots of substituting in this unit. So if x is 3, my equation becomes 3 squared minus 2 times 3 minus 3. So now my order of operations, I do my exponent, 3 squared would be 9. My parentheses, -2 times 3 is -6. Okay, 9 minus 6 is 3, and 3 minus 3 is 0. So we get the point 3, 0. Hey, look, we actually ended up finding one of our x-intercepts. So here's my point 3, 0. If I mirror that, it's 1, 2 away from my axis of symmetry, so 1, 2 away from my axis of symmetry. Here's our other x-intercept, -1, 0. And there's our 5 points. So a difference from factored form is that you don't actually need your x-intercepts. We ended up finding them here, but we could have graphed this with any 5 points. Factored form, you need your x-intercepts. Standard form, you only need your vertex. Okay, so pause and take a look at all of our work. Make sure you understand where we're getting all of our numbers from. And then let's try another example. We're going to do 2 more examples to make sure we understand everything that's going on here. Okay, so y equals -½ x squared minus 1 x plus 1. A is -½ so I know this is going to open down. Then my axis of symmetry, -b divided by 2a. Well, that becomes a -1 divided by 2 times -½ which would really be a +1 divided by a -1. 1 divided by -1 is a -1. Hey, look, there's the x value of my vertex. Now would be a good time to pause and see if you can find the y value. If I substitute that in, this is what it will look like. And again, we're thinking about our order of operations. I have to do my exponent first. I know that -1 squared is a +1. And then I have 2 things I have to multiply here. A -½ times 1 is just a -½ Negative times a negative is a positive. Let's see, -½ plus 1 is a +½ We're getting a fraction, that's okay. So our vertex is the point -1, comma, 1½ My y-intercept, remember that's just my c value, so that's going to be the point 0, 1. So I'm going to put both of these in my table, and then I'm going to graph them. So I've got the vertex -1, 1½, and then I've got the y-intercept 0, 1. Okay, well here's my axis of symmetry at -1. And then remember 1½, I'm just going to estimate. 1½ is up 1, but not up to 2, so it's just right between 1 and 2. Okay, and then my y-intercept is the point 0, 1. And then I can mirror that. So if I have the point 0, 1, if I go to my axis of symmetry and then 1 to the other side, I've got the point -2, +1. Hey, look at that. I almost have a parabola. But I need to get 2 more points for my 5 points. So I'm going to pick an x value. I've used -1, 0, and -2. I could do -3 or +1. So I'm going to do +1. And of course, we're going to substitute that in to our equation. Again, it'd be a good idea to pause and see if you can do this for yourself. Make sure you understand the order of operations. 1 squared is 1. So I get -½ times 1 minus 1 plus 1. Well, -½ times 1 is a -½ minus 1 plus 1. Hey, this minus 1 plus 1, I know that that's 0. So really a -½ plus 0 is just a -½ 1 -½ 1 -½ And again, it's not quite to 1, it's just halfway between. And then, of course, I can mirror that point to the point -3, -1/2. And there's my 5 points, and there's my parabola. Notice that this time we didn't find our x-intercepts, and again, that's okay. Right, this one would have x-intercepts that aren't integers. They'd have decimals as your x-intercepts. Let's do one more. All right, same idea. So again, a good idea to pause, see if you can figure this out for yourself. This is going to open down since a is -1. Negative b over 2a, hopefully you have that formula memorized by now, becomes -2 over 2 times our a value of -1. Well, that's really just -2 divided by -2, which is +1. So 1 comma something. All right, let's substitute. Y equals a negative times 1 squared plus 2 times 1 plus 6. Okay, order of operations, 1 squared is just 1, so then it's a negative times 1 plus 2 times 1 plus 6. Negative times 1 is -1 plus 2 plus 6. -1 and 2 is 1. 1 and 6 is 7. There's my vertex. My y-intercept is, of course, my c value, so 0, 6. So I'm going to take a second. I'm going to put what I know in my table and then on my graph. So my axis of symmetry just happens to be 1 again. Lots of 1s in this video. And then my vertex would be the point 1, 7. So that'd be up here at 1, 7. And then we said our y-intercept is 0, 6. And we can mirror that to find the point 2, 6. We are almost done, but we need 2 more points. So since I have 1, 0, 2, I'm going to pick 3. I could pick -1, but if I don't have to do the negatives, right, I could just pick the positive option. Again, I could do maybe 4. That would probably fit on my graph. If I pick 5 or 6, those are getting less likely to fit on my graph, so that's why I'm picking something that's close to the x values I already have. It really doesn't matter because they're all going to be points on your parabola, but again, we're finding them so we can graph them, so it'd be nice if they would fit on our graph. All right, so we substitute 3 in. Well, we have to do the 3 squared, which is 9. Okay, then we multiply. A negative times 9 is -9. 2 times 3 is 6. -9 plus 6 is -3. -3 plus 6 is +3. The point 3, 3. 3, 3. And then again, we mirror that, and we find the point -1, 3. And look at that. There is our parabola. And I sketch the rest of it the best I can. So that's our standard form. So standard form, what we need to do is we use that formula. You have to know this formula. Oops, bad color. We use that formula to find the axis of symmetry. Once we have the axis of symmetry, we can use that x value to find the rest of our vertex. And then from there, we can find